Hello and welcome to today's, I know that I've been here for a while just talking to you, but welcome to today's session for Crack Maths, and this is the last live session of this year, but I will be continuing with live sessions next year, so make sure that you keep an eye on the website and I will put up the timetable as soon as I have it finalised. I think I'm going to tweak the times a little bit just to help people when they're more available, if that makes sense. But in today's session, what we are doing is we're looking at graphs. So in graphs for functional skills level 2, there's only really two types of graphs that you have to think about. And these are conversion graphs and scatter graphs. Okay, so the main thing that we do need to know about any graph that we have though is the topic of graph scale. Okay, so scale is the main thing that holds us back when it comes to graphs. So let me draw up a quick mock-up of a graph here. So let's say I've got a graph like this. So here's my two axes. Now what we always have when we have graphs is we've got our two axes. This is the y-axis and this is the x-axis. In functional skills maths, when we're looking at graphs, these are actually usually labelled as something, okay? So we might say that, well, let's say that this is a scatter graph, okay? I'll say that this is a scatter graph here, and I'm going to compare two things. I'm going to compare temperature versus ice cream sales, okay? It's usually something like this, ice cream sales. So what I always have is I'm going to have one of these different things on each axis. So let's say that this one's temperature and this one is sales. Okay, I'm just going to shrink this a little bit. Okay, so there we go. And then we can see that. Now, what we always... let me scroll down. Sorry, technology isn't really working today. Right. Okay, right. Anyway, so I can't seem to get that to scroll down, but that's fine. So what we've got here is we've got temperature versus ice cream sales. So on one axis we'll have temperature, on the other we'll have ice cream sales. So let's say what I'm going to do is I'm going to do kind of what we kind of have. So I'm just going to mark on some of the data points, because the largest thing that we have to do in functional skills maths is work out where our scale is. So let's say here, I'm going to say that this is 10 degrees, this is 20 degrees, this is 30 degrees, this is 40 degrees. Okay, you might be able to spot from this that if this is 10, 20, 30, 40, that in the middle, these ones are going to be 5, 15, 25, and 35. Okay, but sometimes it's a little bit harder than that to work out. But what we'd want to do, yeah, but for this one, it was nice and easy. But let me show you how we could have worked out what this was if it was slightly harder. So what I could see here is that for every 2 squares, I was going up 10 degrees. So I'd say here that 2 squares equals 10 degrees. Therefore, if 2 squares equals 10 degrees, I can halve both of these and get that 1 square equals the 5 degrees. Okay, and that's and that's what I did here. So the 1 square equaled the 5 degrees. Okay, now let's say on this other one, let's say we've got sales here. So this time I'm going to say, let's go back to black. So I'm going to say that this was 50 sales, 100 sales, 150 sales, 200 sales. Okay, so that's the sales of ice cream. So what we've got on here, we've got 50, 100, 150, 200 sales of ice creams. Now here we can see that on this one we've got that 2 squares equals 100 equals 50 sales. Okay. So if I was to follow this, what we'd do is I wanted to know how many sales by 1 square. I'd do that 1 square equals 25 sales. Right, sorry about this. I feel like I've lost my rhythm today. But that's fine. Right, so we've got here 1 square equals 25 sales. Now, let's see if... Okay, so I've got... So I can then know, if I was to have to put in this extra bit of information here, I could put down here that each one of these bits is 25. Oh, well, and I wouldn't just put 25 there. I'll put 75, 125, 175, and that would be 225. Okay, right. So I've said that we're looking at a scatter graph here. So what I'm going to now do is I'm just going to put on some random points that might appear on a scatter graph. So let's say I've got some points, and let me do them in blue, just so we've got a different colour. So if I've put a point here, a point there, a point there, a point here, a point here, one here, one here, one here. I'm putting them all nicely on the crosses. Okay, so a scatter graph here, a scatter graph is when we have data points that are deliberately placed that have 2 pieces of data on them. So, for example, if I drew this scatter graph here, and I looked at this point, this particular point here has come from some data that has told us that on a day when there were 200 sales, it was 40 degrees. Okay, that's what we've been told here. So when 200 ice creams were sold, it was 40 degrees. Let's look at another piece. This bit says, on a day when there was 225 ice cream sales, it was 30 degrees. Okay, and another one here would say, on a day when there was 75 sales, it was 10 degrees. Okay, so this here is a scatter graph, and that's how the data is placed. I'm going to move on from this shortly, and then we'll look at quickly a conversion graph, and then we'll go on to exam questions, and I think we'll be doing well. Okay, so this is a scatter graph. The data is placed like that. Let's say, for example, I had to place a different piece of data on it. So let's say I've got a new piece of data to place, and my new data has to be placed at, so we're told that on a day when it was 30 degrees, on a day when it was 30 degrees, there were 150 sales. Okay, if I wanted to put this piece of data on my graph, what I'd have to do is I would have to look for 30 degrees. So 30 degrees is over here, and then I'd have to look for 150 sales and put that on here. So that's how I would place this piece of data. So this bit of data here relates to this information here. Okay, now the other thing with scatter graphs is the line of best fit. So a line of best fit looks like this. It's a line that goes through as many as the points as possible, but doesn't exceed the data. Okay, now the reason it doesn't exceed the data is because on a scatter graph, we only have the information for the data that we have. Okay, so we cannot presume that the relationship between temperature and ice cream sales continues beyond the data that we have. But we can use the line of best fit for estimating values that we might not have. Okay, so say for example, I wanted to know, I can actually see quite clearly here. I can clearly see that if I read up from 125, I can see that that links directly to 25 degrees. So I could be like, I can now use my line of best fit to find information or predict information about the temperature for ice cream sales that we don't have. So here I saw that I didn't have, if I wanted to guess how many ice cream sales would be done on a day when it was 25 degrees, I could see that that could be 125 sales. Right, let's move on because this is quite chaotic. Okay, so let's move on to the other type of graph. Well, actually, let's just move on to some exam style questions, okay? Because I think that's going to make a bit more sense. So let's move on to some exam style questions and we'll do that there. So here we go. All right, 1 second. I need to just refresh this. Oh dear. How is everybody doing, by the way? Is everybody excited for Christmas? Let's see what's going on. Back. Oh dear. Right. I've got a tablet here. Yeah. Why haven't they uploaded? Oh dearie me. Right. Okay, so let's settings. I'm just gonna storage, check sync. Okay, back. Right. Okay. I'm really sorry about today. I think if I was you, I'd just leave me here and have a look at some of the lessons on Crack Maths. Some of the things that we do have on Crack Maths is I actually do have a more laid out definition of scatter graphs and a more laid out definition of, oh my gosh, scale, using a graph scale. Okay, right, but let's use a conversion graph here. So what we've got is, okay, so let's go down here. So I'm going to draw another graph this time, and this is a conversion graph. Okay, and a conversion graph is a graph that just leads you from one thing to the next. So, so let's say I've got pounds. Let's say we're converting between pounds and kilograms. Okay, so pounds and kilograms are both weights. This is a very common thing for a conversion graph to do. So we could have kilograms on the side here, and we could have pounds up here. Now, I'm going to just label some of these. So I'm going to go up here in twos. So 2, 4, 6, 8, 10, 12, 14. And here we're going to have, I'm going to go up in ones. 1, 2, 3, 4, 5, 6, 7, 8. Now, I know that with pounds to kilograms, I know that 1 pound, that 1 kilogram equals 2.2 pounds, okay? So this is what we kind of have to show on this graph here, but you're usually given the conversion graph anyway. So, but if I know 1 kilogram is 2.2 pounds, if I'm up 1 kilogram here, I can see that that's going to be just above that point there, so that'll be 2. I know that if you've got no kilograms, that's no pounds. And if I'm at here, I've got 2 kilograms would be 2 lots of that, so 2 kg would equal 4.4 pounds, so that would just be up here. And then 3 kilograms would be another lots of 2.2 g, so that would be 6.6 pounds. Okay, and it's kind of going to go up like this. Now your conversion graph should be a straight line, okay? And then once you've got your conversion graph, you can use this for anything you want. So say, for example, I wanted to know how many kilograms is £5. Well, what I can do is I can look for £5, which would be halfway between 4 and 6. So I'd read over here, and then I'd read down, and I could see, if I use a more accurate pen, what I could see here is that this goes over to here like this, and then we go down here, and that would be about 2.2 kg. And so I would know that £5 would equal 2.2 kg. Okay, let me just see if the questions have loaded. Otherwise, they haven't, and I don't know why. I'm going to go back here. Let's have another look. Okay, back. My files. Maybe if I close it and open it again. Okay, right. Let me close it, let me open it again. Yeah, you can see all of my messy desktop today. So here we go. Accept. They still haven't loaded. Right. Let me just close that down. I have to close that. Sorry, I'm really sorry about this. Right, I don't mean to be wasting anyone's time. Let's go here and here. Drag them in. So it's this. And they're not doing it. They're just not loading up today. Oh, man. I'm really sorry. Let me try something different. Okay. So okay, so we can have a look at them here anyway, but this isn't as good really. Right. Okay, I'm actually really sorry about today. And I would say if you want to have a go, in fact, why don't we just look at them on the Crack Maths website? So let me go here. I've got. So. Okay, so this has been a bit of a dead end today. Okay, I hope the brief explanations that I've done for you are useful. But if you do want more practice on this topic, I have actually made some videos on this topic which are a bit better. And if you ever, I don't know if many of you have been using the Crack Maths website. Here we go, you might have been using this. This is interesting. This is a place where you can go to, so this is the timetable that I've been having up for the live lessons. So the live lessons have been here. And yeah, so this is what I've got. I'm going to load up a new timetable here for the rest of the year. And if you had wanted to access any of these things, although you've got the image here, what I'd done was, and I will do this again, I linked the PDF and the graphs. So for example, I hadn't put a link here, but if you had, well, maybe I had. 1 second, something's happening. Let's see if something's happening there. No. This really isn't good. If you'd clicked here, some of these things had links on so that you could go to the resources that are available. But anyway, let me tell you about the place for graphs. So if you want to do more work on graphs, what you can do is if you click on resources and tutorials, what you'll find is, oh dear. Just waiting for that to happen. I think I've thrown it off. Here we go. If you go to the tutorial section, I actually do have a section here at the end called graphs, okay? And in the graph section, I've actually got 4 lessons that are here. So we've got how to plot coordinates on a coordinate grid, how to identify the scale on a graph, how to spot positive and negative correlation, and how to make estimates using a scatter graph. So actually, let's first of all just quickly have a look at what I've got over here. So here is a tutorial that I've done for this, but here what you can see is some questions. So they're actually very small to look at here, but I can kind of zoom in. So if I had here this question, and this question was all about marking the point 2, 3 on the coordinate grid. Now, with here, we've got the 2 and the 3, and this is always done x and y, okay? So if I wanted to plot that point 2, I'd have to find the 2 on the x coordinate, so that would be here, and then I'd have to go up 3 on the y coordinate. So plotting the point 2, 3 would be to put a point here, okay? So that is the first of those topics, how to plot on a coordinate grid. If you know how to do that, great. If you don't, you can watch the video. The next one is, and I think this is probably the most useful video out of these lot, it's how to identify scale on a graph. Okay, so here we go. Let's have a look here. And this is kind of what I was getting at earlier. Okay, so here we go. How many people had the favourite colour yellow? Okay, so here is a graph. This is actually a bar chart. We don't see many bar charts in functional skills maths, but what we see them for is we might see them for a scale question. Okay, but let's have a look here. We've got the bar chart, and the question I said, how many people had the favourite colour of yellow? So what I can do is I can see this is the yellow bar. Now, what we can see is we've got up to the thick lines, we can see that there's clearly 140 people here on this thick line. But what we need to do here is we need to see what's going to go on here. So we know that from 140 up to 160 takes 20 squares, okay? So we can see that that is going to be 20 squares. Okay, 140 to 160, well, 140 to 160 isn't 20 squares, it's 5 lines, but it's a 20 thing. Okay, so let me actually just let me just get my tablet up again for that. So here we go. In fact, you know what? I can do what I did the other day. So I can have this. I can get that. I can get the screen share. I just want the screen share. I don't want this. I want this. I just want the screen share. Okay. I can move this to the side and I can have it as a little notebook. Okay, so we can see that 20 lines, okay, so not 20 lines, a value of 20 is 5 lines. Okay, so if a value of 20 is 5 lines, I can do 5 lines equals 20. So then one line, I'll divide this by 5, and one line will equal 4. So I know that each of these little lines is going to be 4. So if I know up to here is 140, then I've got 3 additional lines that I've got to go up. So that's going to be 4, 8, 12, okay? So I'm going to add on 12 for that. Now, I just noticed, if I look really closely at this looks like it's a tiny little bit above that line as well. So I think if we imagine splitting this into 4, this is going to be like 1, okay? So what I've got here, so let me bring back my thing, my screen share. So I've got 140 plus 12 plus 1. So I would say here that we've got 153 people that have a favourite colour of yellow. Okay, so that there is that topic. Let's have a go at that with another graph. And then, yeah, okay, perfect. So let's see this one here. So this is a direct proportion graph, again, where you can use it to convert between days and years. Okay, so, well, let's see the question they said. How many years is represented by one small square on the horizontal axis? So the horizontal axis is this one here. So that, and it's the years, and I think the question said years as well. So what I can see here is that we go up in tens, but we're going up in sets of 5 squares. So if I get my, I don't want that, I just want this. So if I get this again, what I can see for this question is that 10 of these small squares, 10 small, no, not 10 small squares, I'm all over the place. 5 small squares equals 10 years. Okay, so if 5 small squares equals 10 years, that means one small square will equal 2 years. Okay, so remember, always identify how many squares represent the big thing. So here we go. So now let's have a look at finding out the value of this point. So this point here is down here. So I could see that it's 30, 32, 34. So this point here would be at 34 years. Okay, if this one's at 34 years, now I can see that this one here, if I look at this dot looks like to me to be exactly halfway between the 10,000 and the 1,500. No, the 10,000 and the 15,000. Okay, so we've got 10,000 and 15,000. So that dot's halfway between them. So what I could do for this one is I could just, if I want to find the halfway point, is I can actually do what I've done for finding the midpoints. So I just add these together, which will equal 25,000, and then divide that by 2. So if I get my calculator, here we go. Let's turn it to basic. So here we go, so I can do 25,000 divided by 2. So that would be 1,000, that would be 12,500. So I could say that 34 years is 12,500 days. I wonder if that's true. If this is true, well, we know that there's 365 days in a year. So let's have a look. 365 times 34. Oh, right, well, it's very close. 12,410. Oh, nice. So the conversion chart works. Okay, well, that's good to know. Right, okay, so that's us just using graph scales. Let's go back to... let's go back to the other ones. So we've got here how to spot positive and negative correlation on a scatter graph. Okay, so I'll click on this. Now this is quite straightforward. You might be aware of this already, but we'll just have a quick look, as this was the live lesson on graphs. It'll be pretty good actually if we cover all of these things. Remember, all of these things do have videos on them. So if you do need more help after this as well, you can watch the videos. So I'm going to go to this one here. So this is a scatter graph question. So here we go. These are the scenario questions. On the Crack Maths website, I've tried to, basically what I've done, if you haven't been on it yet, is I've put all of the topics into 70 tutorials, and we've got what I've called practice questions, which are ones where we don't have any context. And then I've got scenario questions on each one as well. So, yeah. Thank you so much for watching, the person that's watching at the moment. Yeah, this has been absolute chaos, so thank you for sticking with me. So here we go. What I've got here is the practice question. So But scatter graphs make far more sense in scenarios. So let's have a look at this. So what we've got here is it says, describe the relationship between traffic collisions and temperature in terms of correlation. Okay, so on a scatter graph, what you find is, let me get up my little notepad. On a scatter graph, what you find is you've got your data, and your data goes like this, or your data goes like this, or your data looks like this. Now what we do is we call these either this first one here we call positive correlation. And this is when both things increase together. And that is not how you spell positive correlation, but let's get rid of that. Positive correlation, I don't know. Right, this next one here is called negative correlation. And that's when the points do different things to one another. That's it. That's when one of them is increasing and the other is decreasing. And this last one here, this is when we have no correlation, okay? So that's when there's no link between what they do. So positive correlation is when they both increase together. Negative correlation is when one increases, the other decreases. And no correlation is when there's absolutely no connection between them at all. So if I look at these ones here, let me just move that over there. So if I look at this graph here, this is an example of negative correlation because when one of the values is increasing, the other is decreasing. So if they asked you in this question here to describe the relationship between traffic collisions and temperature in terms of correlation, you would say this is a negative correlation. If we were asked, like in question 2, to describe this relationship in words, we would say, as the temperature increases, recorded traffic collisions decrease. Okay? And that's that. So as one of them increases, the other decreases. Let's have a look at the one on the next page. Here we go. So this time we've got a different scatter graph again. Now the questions this time are going to be the same. They're going to be describe the scatter graph in terms of correlation and describe it in terms of words. Well, with this one, correlation, what we'll see is it's positive correlation because they both increase together. And in terms of words, what we'd say is as somebody gets older, their visits to the GP increase. Or as your visits to the GP increase, you get older. But I don't think it works that way round because I don't think somebody ages by just sending them to the GP. That's what that would be suggesting. So this is important about scatter graphs. The correlation doesn't imply causation. So but sometimes it does. So for example, being older does suggest that you might have more visits to the GP. Having more visits to the GP doesn't impact your age, but all we do in functional skills maths is we just observe the relationship. We don't say that one thing is one thing or another thing is the other thing. We just say this is how it goes. This is what's going on. There's a positive correlation. As the age in years is increasing, the number of visits to the GP is also increasing. Okay, let's have a look at the last of these ones, and then I feel like I've kind of got onto a bit of a roll now again. So, well, I'm not sure if we could call it that. But let's say after this, I'll quickly look at the last one just to conclude this session as an all-encompassing thing for graphs. So here we go. We've got no correlation because there's absolutely nothing linking them. The computer actually did put a slight line of best fit here, which does suggest maybe it's got a slight negative correlation, but that's no worries. Anyway, so what we can see here is that on our axes we've got daily hours spent on your phone. Here we've got length of daily commute in minutes. And what we can see is that there is no correlation between your length of daily commute and the number of time spent on the phone. Okay, right, let's go back. Let me go back, and then let's have a quick look. Oh, okay, that's fine. Just a quick look at this last one. Here, is how to make estimates using a scatter graph. And I think we've kind of covered that in the first thing, actually, but we might as well have a quick look. How to make estimates using a scatter graph. Remember, if you do want more work on these, you can come and visit crackmaths.co.uk. Hopefully, it will run a little bit faster for you than it is for me today. But we'll find out. Right, so here we go. Here we go. We're next to it anyway. So, right. So, what this topic means, making estimates using a scatter graph, entirely relies on your ability to just use this line of best fit. So what I've got here, it says, if on one day there was 20 traffic collisions, use the scatter graph to estimate the temperature on the day. And we kind of actually looked at that already. So 20 traffic collisions. Okay, so here we go, 20 traffic collisions. So we'll read over at 20 and then we'll read down. So that to me looks like it's going to be 21, it's just over 21 degrees, but I think we could call that 21 degrees. And I know it's 21 degrees because in this circumstance, we've got 5 squares for 5 degrees. So it makes sense if this is 20, this is 21, this is 22, 23, 24, 25. Okay, let's do one more and have a look. Okay, so this one says, how many more visits would you expect someone who is 10 to have had compared to someone that is 2? Okay, let me just bring out this here. So we're looking for someone who's 10 and someone who's 2. 10 and 2. Okay, so someone who's 10, okay, I'm going to read up here. Okay, again, that's relatively straightforward. That looks like 10, looks like it's 11 visits to me. Again, because we're going up in 5s and there's 5 squares, there's no funny business there. So 10 would be 11 visits. Okay, now 2 is all the way here. 2, nice and on the line, would be 4 visits. So how many more visits would I expect someone that is 10 to have had compared to someone that is 2? Well, I'd do 11 take away 4, and that equals 7 more visits. Right, I'm going to call it a day there, and this is going to be my last video now before Christmas. So I will get the new timetable out soon, so make sure you just stay alert, have a check out. If you haven't subscribed to my website, if you haven't subscribed on crackmaths.co.uk, there is a place to, if I go to click to the home page, you can actually subscribe on the website, and then I will send out an email once I've got the new timetable sorted, just so that everyone is aware. Sorry about this. Here we go. We're just waiting to get to the home page. So here we go. You can subscribe on YouTube, but you can also, if you scroll down here, you can sign up for all the latest updates, okay? So, and you can do that there. And if you sign up for all the latest updates, when I have the new schedule sorted out for the new year, I'm going to put that up there. And it's likely to be starting from the first whole week back in January. Okay, so that's probably going to be whatever that Monday is. Let me have a quick look here. And that's going to be... Oh, gosh, I don't want to show you on my calendar. Right. That's going to be... Yeah, whatever that is. Okay, great. Right, anyway. Why can't I find it out? Monday. Okay, well, I think it's like Monday the 6th, I think. So we'll do that anyway. Right, okay. Anyway, so long, goodbye. Thank you very much for watching and have a lovely Christmas and New Year. Okay, bye.